Hello friends, today we discuss about the chapter number 6 of pharmacology. Chapter name is adrenergic agonists, written by Rajan Radhakrishnan. First he started with overview. The adrenergic drugs affect receptors that are stimulated by norepinephrine or epinephrine. These receptors are known as adrenergic receptors or adrenoreceptors. Drugs that activate adrenergic receptors are termed sympathomimetics, and drugs weight adrenergic receptors are termed as sympathomimetics, and drugs that block activation of adrenergic receptors are termed sympatholytics. Some sympathomimetics directly activate adrenergic receptors, direct acting agonist, while others act indirectly by enhancing release or blocking reuptake of norepinephrine. Next, start with the adrenergic neuron. Adrenergic neurons release norepinephrine as the primary neurotransmitter. These neurons are found in central nervous systems and in the sympathetic nervous system, where they serve as link between ganglia and the effector organs. Adrenergic drugs act on adrenergic receptors located either resynaptically on the neuron or post synaptically on the effect organ. Here you can see all the drugs names. Firstly, direct acting agents, indirect acting agents, and direct and indirect agents. No neurotransmission at adrenergic neurons. Now we see that what is neurotransmission at adrenergic neurons. Neurotransmission in adrenergic neurons closely resembles that described for the cholinergic neurons, except that norepinephrine is the neurotransmitter instead of acetylcholine. Neurotransmission involves the following steps: synthesis, storage, release, and receptors binding of norepinephrine, followed by removal of the neurotransmitter from the synaptic gap. Next, synthesis of norepinephrine. Tyrosine is transported by carrier into the adrenergic neuron, where is the hydroxylated to dihydroxyphenylalanine by tyrosine hydroxylase. This is the rate-limiting setup in the formation of norepinephrine. DOPA is then decarboxylated by the enzyme aromatic amino acid decarboxylase to form dopamine is the presynaptic neuron. नेक्स्ट चलते हैं. Storage of norepinephrine in vesicles. Dopamine is then transported into synaptic vesicles by an amine transporter system. This carrier system is blocked by reserpine. Next, dopamine is hydroxylated to form norepinephrine by the enzyme dopamine beta hydroxylase. Release of norepinephrine. An action potential arriving at the nerve junction triggers an influx of calcium ions from the extracellular fluid into the cytoplasm of the neuron. The increase in calcium causes synaptic vesicles to fuse with the cell membrane and to undergo exocytosis and expel their contents into the synapse. Drugs such as gonethadine block this release. Binding to receptors. Norepinephrine released from the synaptic vesicles diffuses into the synaptic spaces and binds to both synaptic receptors on the effector organ or to presynaptic receptors on the nerve ending. Binding of norepinephrine to receptor triggers a cascade of events within the cell, resulting in the formation of intracellular second messengers that act as links in the communication between the neurotransmitter and an action generated within the effector cell. Adrenergic receptors use both the cyclic adenosine phosphates. Second messenger system and the phosphatidylinositol cycle are transduce the signal into the effect. Norepinephrine also binds to presynaptic receptors, mainly alpha 2 subtype that modulate the release of the neurotransmitter.